Hello, everyone. This is homework help for week 3. But the questions that came in this week, I only had 2, was from homework number 2, and that was number 6 and number 13. If you have other questions on homework 3, please don't hesitate to give me a shout out via email, and I will make a video for what you need. So this one says, a researcher has been studying the lifespan of a certain bacteria. The preliminary sample of 40 bacteria reveals a sample mean of 80. So we have a sample size of 40 and a mean of 80. It also has a standard deviation of 6.4 hours. You would like to estimate the mean lifespan for this species bacteria within a range of a margin of error of 0.6 hours at 95% confidence level. What sample size should you gather to achieve a 0.6 margin of error? Round your answer up to the nearest whole number. Okay, so basically what a confidence interval is you take a point estimate and you plus or minus a margin of error, right? So that's like when people say like, oh, he's leading the polls at 57% plus or minus 2. That means he's really somewhere between 55 and 59, right? Depending on how big that margin of error is, tells you how accurate you're going to be. Obviously, the bigger the margin of error is, the more accurate you are. You can think of it like if you're trying to shoot a target. The bigger the target, the more likely you're going to hit it. And the less useful it is. Like, oh yeah, I hit this target. Well, if the target is the size of a barn, you're actually not shooting very accurately, right? So that's the idea with confidence intervals. So there's my bell. So what we're working on here is this idea. This margin of error is calculated in a certain way. It is calculated by taking a critical value based on your distribution. In this case, we're assuming it's a normal curve. So we're taking some cutoff values based on how much data we want. So if we want to be 80% confident, we have 80% of the data in the middle. We want 90%, we'll be 90% in the middle, and so on. So it's going to be a critical value times the standard deviation divided by the square root of the sample size. That's how this is made. Now, if we want this margin of error to be a particular number, like 0.6 in my problem, and they tell us that we want to be 95% confident, so we have our 95% in the middle here. I need to find the cutoffs that go here and here. I can do that by grabbing my calculator. If I am using a TI-84, which I typically am, okay, then I would go second distribution. So second bars, which gives me the distribution key. Choose inverse normal, which is number 3. All right, area, I'm just going to put 0.95 here. Mean is 0, standard deviation 1, and it says tail, I want the 95% in the middle. So I put center. I hit enter, and it gives me negative 1.9599 and 1.599. Now, if you don't have a center button and you're using Excel or something, then you would tell us what you would have on the left tail. There's 95% here, there's 5% combined in these two tails, which means that each tail has 0.025 area, right? 5%, and there's 0.95 area in the middle. All right, so here's our critical value. We'll use the positive one. 0.6 equals 1.96 times our standard deviation, 6.4, divided by the square root of n, because we're looking for our sample size, right? we're looking for how big a sample size do I need, right? So I'm going to solve this for n using basic algebra 1 skills. Multiply both sides by the square root of n. Go ahead and multiply my 1.96 times 6.4. And I get 12.544 divided by 0.6. I get square root of 20.906, square both sides, get rid of the square root, and I get n equals 437.088. Okay? Round up to the nearest whole number, 438. Right? Not down, always round up because you want to be like a little bit more. All right, so 438 is my answer for my specific problem. But while I'm at this, I just want to tell you that in your book, there is a formula for this. But let me show you how that formula is derived. Okay. So remember that we're looking for a margin of error. And I just told you that our margin of error is our z-critical value times our standard deviation divided by the square root of sample size. That's how you build a confidence interval. You use algebra 1 to solve this for n. And multiply both sides by the square root of n. Then divide both sides by the margin of error that I want to have. Then square both sides. N equals your z-critical value times your standard deviation divided by the margin of error you wanted, everything squared. And that's the formula that you will see in your textbook, right? So if you write that formula on your notes somewhere, then you don't have to do the algebra each time you do it. All right. And our next problem is problem 13. But there is no problem 13 on this. Did I go to the wrong week? Um, 6 and 13. Maybe she meant 12. Let me double check her particular one. Okay, maybe I am in the wrong semester. Like, I'm in Stats 243. Okay, that might have been a whole superfluous problem. I might have been in the wrong Canvas shell. I apologize. Pretty ridiculous of me. I apologize. That should be the right one. Yeah, sorry, I picked the one that said April 2023 instead of April 2024. All right, let's try this whole thing again. I apologize. This is actually a really useful problem, but I will make a new video for this. So I'll post this video anyway because it's good. All right, so there you go. Let me make a new one. Bye.